The nanodroplet has come to rest in the Rocky Mountains. Looking at the Teravator's thermometer, boy, it's really cold out there. We should expect our water droplet to be in frozen form, as an ice crystal, as it falls through the cold air over the mountain. It is probably precipitated as snow. Let's land the Teravator and look for our droplet. Let's take a look around and see what we can find. There's a large snowbank here. Maybe we should get closer and investigate. There's a lake here that is completely frozen. Let's hike over and check that out. There's a pile of boulders here. Perhaps they're worth a look. I wonder where these boulders came from. Could the snow and frozen water have helped create all of the boulders? Let's gather some data to help us test our idea. The snow is cold. It's well below freezing. The snow precipitated from the moist air moving up the side of the mountain. In general, when it snows a lot, it really piles up. Here it is so cold that the ice is not melting. It is accumulating into thick snowpack. Some of this snow has, over time, been packed into a solid block of ice. The whole thick ice block has become so heavy that it's actually being pulled by gravity and moving down the mountainside very slowly. As the ice block moves and grinds over the mountain, it plucks chunks of rock up and carries them along. It also grinds off tiny bits of rock in a fine sort of rock flour or powder. We call these moving rivers of ice glaciers. Glaciers are thick masses of ice which flow over time, like rivers of ice. Gravity pulls the ice down the steep slopes of the mountain. Let's look closer and see if we can see the effects of this on the mountain. Surely this would, over time, affect the landscape. From above, we can see the smooth, U-shaped mountain valley carved by the glacier at some time in the past when it was much colder and the glacier was much larger. Mountain canyons carved by water alone tend to create sharp, V-shaped canyons. There is a pile of boulders running all the way across the canyon floor. The boulders appear to be creating a natural dam, forming a mountain lake. The boulders are similar to the type of rocks we see in the mountains above. How do we break off pieces of a mountain? Gravity is pulling down on the rock constantly, but it appears to be one giant solid block of rock. These boulders in this pile are individual pieces. Let's check in with GeoGarage and see if they can help us understand how these boulders may have formed. When glaciers melt, they drop their rock load. And when the glacier melts and retreats, a pile of rocks forms. We call these piles moraines. Across the bridge is a frozen pond, but it appears that the pond isn't completely frozen. Some liquid water is running out from the pond and down the hill. Let's follow the stream and learn more. Some of the water is trickling into cracks in the boulder. Tonight the air temperature will plummet and the ice will freeze. What happens when the water freezes? Does it expand or contract? Let's call GeoGarage and set up an experiment so we can find out. Ice has an important role in breaking down rock. As water freezes, the volume of ice increases by 9%. This creates enormous pressure inside the rock when water freezes in a confined space, as in our experiment. Melting is the transition of water from ice back to liquid. Water is, in its frozen or solid state, below 0 degrees Celsius or 32 degrees Fahrenheit. The air temperature here has risen to 33 degrees Fahrenheit, and so some of the snow is starting to melt. This liquid water is flowing down the hillside, being pulled downhill by gravity. This little trickle of water will become part of a great river further down the mountains. As the streams get larger, more and more bits of rock will get moved with it down the hill. Weathering is the breakdown of rocks into smaller pieces that we call sediment. Ice begins to break down the mountains here into boulders. As water finds fractures in rocks, it will squeeze in, and at nighttime it'll freeze, and then expands the rock until, snap, it breaks into two pieces. Over time, this is how we weather rock into sediment, which eventually erodes away and gets flushed into streams and rivers, deposited in oceans and lakes. Sediment are natural bits of rock that range in size from these giant boulders to the tiniest of flakes of clay. Sediment is created through weathering of rock and can move from place to place by water, wind, ice, or gravity, a process we call erosion. The nanodrop is escaping down the mountain in our meltwater and joining other streams to form the new Arkansas River. Now that it's warming up, let's get in the Terravator and follow it downhill.